people environmentally conscious recycle. How about that? Okay, so homework is both of these assignments, 15, 6, and 7. If you are not with us today, hopefully you're back with us soon. The mastery will not be Friday. So if you're watching this from home, our mastery will be sometime next week. So we got this mayor. He's buying recycling bins for town hall. Now, he wants to decide what color to use. If you need notes, they're right there. So he decides to survey his city hall workers. Should he use a convenience survey or a systematic survey to try to get input that represents all the workers? So you think convenience or systematic, and why? So take a moment, write on your paper, either could be right. It's all how you justify it. What evidence do you cite for why you made that choice? Yeah. They're right here. People that were streaming in late, I just left the staff right here. Yeah.
I was going to say.
Oh, hang on. Just write out your answer first. Take a moment. Both could be right.
Wait, never mind, because now I'm torn between two.
Yeah, I get you. Why in the store do you see fishy bones starting to melt down?
I guess let's converse about this. Conversing is fun. Who thinks a convenience sample would be better in this situation? Who thinks systematic? Okay. Convenience. Why? Yeah.
Because I'm guessing the mayor does not have a lot of free time to just go out and go ask for a systematic sample.
Yeah.
So he probably just needs to just grab a bunch of people off the street and ask them.
So you're saying convenience because it's fast, and we're actually only talking about city hall workers. So I wouldn't even have to go grab people off the street. I could go to maybe there's a lunchroom in the city hall or something, and I could just survey those people. So it's fast and easy, right? And the mayor does not have much extra time. So he doesn't want to spend a lot of time on this, so it's fast and easy. Let's just use a convenience. Cool. Zach?
So, if there's a meeting or something, it would be pretty easy
Yeah.
to do,
He's the mayor. He probably has lots of meetings. He walks in a meeting and says, before we start the meeting, what color do you want our recycling bins to be? Fast, easy, done, move on.
Why does it matter?
Because it's a math problem.
That's a really good question, actually.
I mean, it's
Does-
just the color.
Does the color of the recycling bin matter that much?
No.
No. So another reason for using convenience is it's not a big deal. When you are surveying something that doesn't really matter that much, you may not care if your sample is representative. What he may care about is saying he didn't make the decision, he asked other people. So he can defend what he chose by saying, I surveyed our workers and they told me to order green. And then it wasn't he made the decision. Have you ever heard, okay, this gets dangerous. CYA really means cover your butt. But a lot of times you just want to be able to protect yourself. And the mayor could get in trouble if he's making decisions on his own. So when he says I did a survey, people aren't going to probably ask, well, how did you collect the data?
I covered my butt.
They're just going to say, oh, you collected data, great. So a lot of times when I ask other people and then I do what they tell me, I'm not afraid because somebody else told me to do it. That's probably the mayor's situation here. So systematic. What's some reasons for using systematic? James?
It's less likely to be biased.
Yeah, so it should be unbiased, we can say. Should be. What else? Cheap?
You also can get a bigger pop because you have to get all the workers, so you could.
Well, we're not getting every worker. We want input that represents all the workers. So I don't actually want to talk to every single person. But I agree, we can get more input then, right? Because then in a systematic sample, I determine how big I want the sample to be. What else? Any other advantages to a systematic? One disadvantage, though, you have to know how big your population is. So he would have to know how many workers there are. He then has to determine how big of a sample do I want. You do the math, population divided by sample size, and that tells you your interval but that's a lot more work to do. So a drawback to the systematic is it is more work. It does take more time and effort. Questions on either of those could be fine. It's all why do you choose what you choose. If he's like most mayors, he'd probably use a convenience because he doesn't have time. Like most mayors do not have enough time to do what they need to do. So when we talk about the different types of samples, there are reasons why we would use
Convenient sampling
each
is
of them
best when
because of their pros and cons. Or
you do not have
disadvantages.
access to all of the members of the
Convenience, you wanna
population,
underline or circle or highlight these as we go.
or you do not have time or resources to use a more accurate sampling method,
Not everybody's there every day.
and the members available are representative of the population, or if it is not important that the sample be representative.
It would be better because I only survey who I have access to, who's convenient to me. Again, talking about the mayor, if you don't have time or resources, mayor doesn't have time. Do a convenient sample. It's quicker. It's easy. Or the members that I have available are representative. So if you know that, say like at Otterbein, we had a student council, and the student council tried very hard to have members from like every organization. Every like Greek organizations were represented, athletics were represented, academic clubs were represented, like housing people, like the dorms, they had people from their committees. So when you look at a group that is representative, then you can convenience sample that because you know your data's good. So if we had a committee that had boys and girls, 7th and 8th grade, that got together like to talk about Phoenix stuff, that could be a good convenience sample because it would represent the whole population. Does that make sense? Yeah, how you sometimes have representative groups. So, systematic
sampling is best when
thing to remember about systematic
the whole population is
when your
available,
data
or a
is
stream
coming
of
by
representative
in a
members are
stream.
available,
So when we're looking at like what example have I
and there is
given
no
on
pattern to the
what
arrangement of the population or the stream of members.
On the street.
If you stand on the street and people are walking by you, or specific to Phoenix, Nate? Yeah, the hallways or like the front door. If I stand at the front door while you guys are getting here in the morning, you're going to stream past me. You have to walk past that door or through that door. So I can get my population to stream past me. The other thing is systematic. You need no pattern. If there's a pattern in your data, even if your data is streaming past you, if there's a pattern, we don't use systematic because systematic will pick up that pattern. It will it'll be biased based off that pattern. And our last sampling method is cheap. Yeah, simple random. Simple random is the best when
Simple random sampling is best when
first thing we have that you want to highlight.
the whole
underline,
population is
the
available,
whole population is available.
or the
whole
characteristics of the
entire
population
everybody
are unknown.
access. If I can't access people, that's not a very good sample. Because you can't access them, you can't use them. And when you don't know about the population. So say I'm collecting data on how many boys or girls are at our middle school. I know that already. I know that information. That's not good to collect. But if I'm trying to collect information on how long does it take you to get ready in the morning, I don't know anything about the population, how long it takes you guys. So I could collect that simple random, and that would be a fair sample. Any questions on the differences between the three of these? Be careful that on your notes, somebody was a little confused by this at one point. You have convenience on the left, and then systematic and simple random. So you might want to like draw a line across here to show that this splits between systematic and simple random just to keep your brain straight. So we have to determine what type of sample this is, but we have to set up the problem first. So the music teacher, so let's say Mr. D is determining how many students in the school can play a musical instrument. So that's the data we're trying to collect. The music teacher is our researcher. They're the person collecting it, Mr. D. How many students in the school can play a musical instrument? So we want to say, what is this? And then off to the right, I want you to write another column for, is it representative? Is it a representative sample? So Mr. D decides Had to get the right set of cards. Don't know how I don't have the colors memorized yet. Mr. D decides to survey every 5th student who enters the music room. So, Rye, what do you think? What kind of sample is it if I survey every 5th student?
Isn't that systematic?
Yeah, when there's an interval between who I choose, that is a systematic sample. Would that be representative?
I don't think so.
Yeah, what's your population?
It's the entire thing. Entire band. Oh,
Your population's in the school. So all students in the school are your population. Would surveying the people who enter the music room give us a representative sample? No, that's completely biased.
Oh yeah, because
If you're entering the music room, you probably have musical knowledge. Now, somebody in a year previously, they said, what if it was like at a canteen or something? Okay, we're assuming they're entering the music room for music class. Like, come on. Which is funny when I can now ask the questions before you guys even do. Your wheels are like turning. How can I prove them wrong? So now we survey the students in the school whose names are picked out of a hat. Grace, what kind of sampling picks names out of a hat?
Simple random.
Yep. If we're picked out of a hat, that is simple random. Now, would that create a representative sample?
Yeah.
Yeah, that is representative because it's students in the school. So I put like every name into this hat and drew them at random. Pranav, if I survey the students, or not I, Mr. D surveys the students in the homeroom closest to the music room. So he'd probably walk over to Mr. Allen's room, say, who plays musical instruments here? What kind of sample is that? Convenience. It's close. All those people are available. They're close to him. Come on, highlighter. So closest makes it convenience. Would that give me a representative sample?
Yes.
Yeah, because that homeroom has nothing to do with musical ability. Homeroom has nothing to do with musical ability, so there's no bias to that data. Now we survey, or Mr. D surveys Lily. He's going to survey all the students in the next band practice. What kind of sample is that?
Would that be convenience?
Yeah, is band practice convenient for Mr. D? Yeah, he's there. It's his practice. Would that give you a representative sample?
No.
No, it's band practice. If you're at band practice, hopefully you know how to play an instrument. Shahid? There'd be very, very few people spectating there. You'd still get a giant bias. So you might get some unbiased, but you'd still get a pretty big bias.
What if it's the first one? Alright, never mind.
And then we survey, Karen, every 10th student who enters the school cafeteria. What kind of sample is that? Systematic, because I have an interval. And is that going to be representative? Yeah, because entering the cafeteria has nothing to do with music. So yes, that gives me a representative sample. Questions on these? Check out your roller coaster problem about and we'll assume Cedar Point. So check out your got it. Try this on your own. Identify what the method is and if it's representative. So our workers are doing research on how many customers like to ride the roller coaster. So that's our question. What's our population?
All the people in the amusement park.
Yeah, the people at the amusement park. Anybody who comes to the amusement park. So, Nate's not here, so Seth, you're gonna fill in. Don't worry, we'll swap when your card comes up. Seth, if I survey every 8th customer waiting in line for the roller coaster, what type of sampling is that?
Systematic.
That is systematic. The interval that tells me what to do, that creates a systematic sample. Would that be representative?
No.
Why?
Because if you're waiting in line for a roller coaster, you probably like to ride a roller coaster.
Yeah, they're waiting in line for the coaster. They probably like it.
I mean,
That's gonna have a bias. Yes, there could be some people in the line that are afraid or da-da-da. But the majority of the people in the line are gonna have a preference or a bias to the roller coaster. Now, also not here, Shahib, if I survey the customers, let's say I got hungry. I was collecting data, I got hungry. I went to the food court. I surveyed the customers at the food court. That is a convenience. It was easy. They're available to me. They're right there. Would that produce a representative sample?
Yes.
Yeah. By eating in the food court, I doubt they have a bias to the roller coaster or not. Now, if I survey every 12th customer who enters the park, Zach, what kind of sample is that?
Systematic.
Yeah, there's a rule that tells me what to do. Would that produce a representative sample?
Yep.
Yes, I would accept answers on either side depending on your justification. Some people argue that if you're no?
If you're entering the amusement park, you probably want to ride the roller coaster.
Yeah, but the other side of that, Fernand, do you know what I'm going to say?
Is that they may not always want to go to the roller coasters because there may be like other times like bumper cars or like.
Think about Cedar Point. Snoopy Funland, the Sky Ride that takes you from one end to the next, the arcade games. All because I'm going to Cedar Point doesn't mean I want to ride the roller coasters. So if you're surveying at enters the park, you assume there's not a bias because they could be there for numerous reasons. But there could be, so if you justified it with evidence saying people coming to the amusement park are more likely to like the roller coaster, then yeah, you could kind of support why it would not be representative. But in general, it would be a representative because you're at the gate. You're not somewhere specific like the roller coaster line.
I'll go to Cedar Point.
I've not been in a few years. I really want to go back.
I've never been there.
It's a cool place. Very cool
That's
place.
what people keep telling me.
It's old. I mean, it's been around for a while. All right, so now you have gone to college. You've become quite successful, and you decide that you're going to become a city developer. So you're laying out a neighborhood, and these houses vary by type based on their color. So on your paper, your colors, you can't really see it, so you might want to take a second to label what the colors are. And while you're labeling the colors, think to yourself, is there a pattern in how these houses are arranged? So you could label them just like R for red, O for orange, or you could label it house type A, B, and C. I'm fine if you just label based on colors. We could even say those are the colors they'll paint the houses. Be kind of a colorful neighborhood. So is there a pattern in how these houses are arranged while they're in the neighborhood? I like to call these places either suburbia or cookie cutterville. But there are a lot of neighborhoods, like Dominion neighborhoods or different, like where they build houses, and they literally say you have option A, option B, or option C. Which one do you want? We'll build it. And sometimes, if somebody just built option A on that lot, and I have the lot next to them, I can't build option A, because they don't want the same house right next to the same house. So I might have to change my lot, or I might have to change what house I choose. So in this neighborhood, is there a pattern? To figure this out, I take a walk.
Well, I noticed that the
Forget about these two because they go to the next block. Lily?
Okay, there is, because if you split it in half horizontally, the top both have one orange, two reds, and two blue, and then the bottom have one orange, two reds, and two blue.
Let's say I take a walk down the street. or down the sidewalk. Don't walk in the street, it's dangerous. I, because I like colors, or you have a little brother or sister or something, they start listing the colors of the houses. Red, orange, blue, red, blue. You cross the street, red, orange, blue, red, blue. It's the exact same. You cross the street and you start walking this way. Red, orange, blue, red, blue. It's the exact same. Cross the street and you're walking this way. Red, orange, blue, red, blue. It's the exact same pattern over and over and over again. So when I am determining what kind of sample I want to take, would I do a systematic or would I do a simple random? And why? Olivia?
Never mind.
Pranav?
You should do a simple random.
Why?
Because if you do a systematic, you will end up with the pattern that you're having, like red, orange, blue, red, blue. You'll end up with the pattern.
So what I need you to notate here somewhere, and I'll probably put it over here, we cannot use systematic because there's a pattern. We know that if there's a pattern, we should not use systematic because that pattern will affect my results. So instead, we use simple random. Now, if I want to use simple random, what's the process that I have to take to choose my houses? We could do out of a hat, but I'd have to like name the houses. Like that one's Bernard, that one's Bernice. Like I don't know houses' names. Zach?
Could you do it by color?
Am I gonna choose every house of that color?
No.
Yeah, I need each house to be individual. Shaheeb?
By neighborhood.
So I need to be able to choose individual subjects. Pranav?
You could use the address of the house.
Ooh, I could use addresses. Nate?
You could like number off the different colors.
Yeah, let's say the houses just got built and they don't have addresses yet. We could just say, okay, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then, so once I number all of them, what do I do? Or use, random number generator. Which actually, I think there's apps and stuff that'll randomly generate things for you. Like randomly flip a coin, randomly roll a die. We're going to get into some statistics or some probability next week. Yeah.
Or you could put a blindfold on, take a baseball, spin around 3 times, and throw the baseball.
See whose window you break?
Yeah.
Yeah. That would work. It would be random. Although, notice, when we talk about random samples, we call them simple random samplings. You never want to choose a random method that's too complicated. So that dances that fine line of complicated. You are now blindfolded throwing a baseball and might have to pay someone for their window. So that's probably not as simple as we want it to be. All right, so think about this. Now you become a police officer. Now you become a police officer. You're deciding whether or not you need to place one of those, like your speed is. You're trying to determine where to place that. So you go to highway, they don't give me the name of the highway here. We go to local highway. And we know that approximately every morning there's 2,480 cars that drive on that highway. I want a sample of 100 cars to see, was that car speeding or not? Would I use systematic or simple random sampling? Now, I'll set this up for you. You're either on the side of the road, like cops pull over and they like watch traffic go by, or you're up on an overpass watching the traffic come by, because you can stand on an overpass and like observe the cars and you could clock their speeds from there.
But don't cops have to be visible?
Yeah. So I've seen cops work together where one's up on an overpass and one is like ready to pull you over. But all because like he's on the overpass, you might not think to look up and actually see him, but he could be up there with a radar gun and then radio, hey, that red Civic is speeding.
Because my mom was we were driving somewhere and she said that it was illegal because
Yeah, they're supposed to have their lights on too, like their four-way lights.
They were like in like the woods and like where you couldn't see them.
There's a lot of like gray area though, because cops get away with a lot. Ryan, what were you gonna say?
I was gonna say, random sampling. It's simple random.
Okay, so let's think this through. How would you choose your subjects then?
You could do like every fifth car or something.
That's not random.
Oh, that is not, is it? Shoot.
See, when you start thinking
Yeah,
through,
yeah.
it's easy to just quickly say one of the sampling methods, but then think through, how am I going to do it? Shaheed?
You could just go, random times, hit the radar thing, and it.
What would determine that? And how will I make sure I get 100?
You can keep track of every single time.
What if rush hour ends before I get 100 though?
Hold on.
I'm really good at posing the problems behind what you guys are saying. What do you think, James? What kind of sample would you use?
I'd use systematic.
Why?
Because it doesn't mention that there's a pattern to the cars, so it's less likely to be biased.
So when we think about the pattern again, like banana buyers, do you think there's a pattern on the highway of who's speeding, who's not? Like I look at the car next to me, oh, they're speeding, so I can't. No. There's not going to be a pattern in your vehicles. And the biggest thing here, guys, your cars are coming past you.
They're a stream.
They're streaming past you. You can easily say every 10th or 20th or 40th car, I'm going to click my radar gun and see, are they speeding? So we would want to use a systematic because they're streaming by us. I'm going to say the population is streaming by.
Are you allowed to have one of those things?
Radar gun?
Yeah.
Sure. Like baseball coaches use it to see how fast the ball's going and stuff.
Yeah.
Some are just more accurate than the other ones. How a police radar gun works is actually really cool. It sends out a wave of like particles or light or however you want to think about it. So say you're the car, right? Hold up your piece of paper. So that's your license plate. I click the radar gun. A wave of particles come to your car. They hit your license plate, but it doesn't only hit once. It hits continuously. When those particles make it back to my gun, they see what's the distance between the particles, which tell me how fast you were going because it will change the distance between you and the gun. So depending on how quick those particles get back to the radar, like the gun, that determines what your speed is. Yeah, so it's using change in distance over change in time, because that's your speed, miles per hour, distance over time. So it's how much distance did you cover in a certain amount of time, and it will actively calculate your speed and change. Yeah, so when I got clocked down at OU, I was going like 72 or something because I was coming downhill. And normally the speed limit's like 65 or 70, like especially as you get into Virginia. It's 75 in some places too. So he clocked me. I didn't believe I was going that fast because I was in my old Jeep that had bigger tires on it. So my speedometer, if you think about the math, when you have a tire of one size and your vehicle is set up to know the speed of that, one rotation covers a certain distance, right? It'd be the circumference. When I make my tire bigger, one rotation now takes me a further distance, and the car doesn't know that. The car just knows it went one rotation. So my car told me that I was going like 63 when apparently I was going like 72. So once you know you're getting a ticket, you have a lot of rights. So I ended up asking the cop, can I see the radar? Like I'm not saying that you're a liar, but I don't, my car didn't tell me I was going that fast. So I went and looked at the radar and he got me. So at that point you got nothing. You just pay your ticket and you learn by it.
How much did you have to pay?
It was like 150 or something like that. Yeah. Tickets pretty much start at about $100. Like a ticket is expensive because they just want your money. Yeah, there's part of it that they care that you were speeding and they're trying to keep you safe and that's their job. There's another side of it that towns want revenue so that they can do what they need to do. So, yeah. So the math of changing car tire sizes is really important. And I realized in that moment, you either go to a dyno, I forget what it's short for, but DYNO, you put your car up on like essentially wheels and you drive in place and they calculate how fast you're going based on your tire spin, and they can recalibrate your computer in your car. Or you just make sure you realize. After that, I just always like compensated by like adding 5 or 8 miles to whatever my speed showed.
I've seen that commercial of the football player, and he was a big guy, and the guy next to him was like, "So you've never been on a treadmill before, have you?" And he's like, "What are you saying?"
I have no idea what you're talking about.
And then like the
So-
commercial ended, and then like the next commercial started.
And then I found $5. Okay, so if you've never heard that, to save a story, just add and then I found $5, because then it makes your story better. So you're now working at a toy factory. Maybe you decided not to go to college and you just got a factory job. That's okay. It used to a lot of people used to do that. My grandpa did that. Or maybe you went to college and you're just starting out. I've got a lot of friends that in college they worked at FedEx or wherever else. So you're checking toys. You got to make sure these toys are safe and not defective. They're made by 6 different machines. They're all in a line, and they plop them all down to the same conveyor belt and move them on down the line to get boxed up. You want to collect a sample of 75 toys. There are 600 toys made every day. Would we use a convenience sample or a systematic sample? And why? Would we use a convenience or a systematic, and why? Ashton, what do you think?
I'd say systematic.
Why?
There's no pattern on the conveyor belt.
Yeah, there's no pattern in the toys. We can't assume that every 10th toy is broken. Like, that wouldn't make sense. So, there's no pattern. And if I want 75 toys, if I did a convenience sample, what do? Choose the first 75 toys? Like, if you're thinking about when will the machines break down or things like that, that would have a huge bias to just the first 75 toys.
Right.
It's much easier if I choose a systematic, also because a conveyor belt, some of you guys might not know what a conveyor belt is. A conveyor belt makes your items stream past you. So again, it's that whole stream, but you can put that in quotations since it's not really a stream like water or something like that. But stream is really just used to represent things are coming past you. That's why the water's going past you. It's a stream. So if I need a sample of 75, we got to review how to do that process, right? I've got 600 in my population. I need to determine my interval. How do I choose? I choose every what number of toy. So I need to solve my interval. How do I solve for my interval? Population over... Yeah, population size over the sample size that I want. So my population size is 600. The sample size I want is 75. Do not touch your calculator. You should realize that 75 nicely becomes 150 when we double that. Then if I double that, it nicely becomes 300. And if I double that, it nicely becomes 600. And we get an answer of 8. So we will choose or check or inspect, whatever you want to say, every 8th penguin or whatever they said they were making. They're toys. I don't know. I like penguins. So, there you go.
So do I.
Penguins at the zoo are always fun. But they're not edible. They're toys.
Right, they're jelly bean toys.
Like Mexican jumping beans. They have that weight inside of them that, like, as the weight moves, it makes it look like it jumps. Yeah, we can skip this. Let's move on to 15.7. So, to build morale, what's morale?
Like your
Not moral, like you having good morals, but morale.
like an employee, like a manager does stuff to or like the owner of the company does stuff to boost the workers' morale, which is basically like how they do. I don't know how to explain it. It's
Can't
like
define a word with a word. No? Kind of. Morale is just kind of like how you feel. How the group together, like, feels or works together. So, like, if somebody says your team has bad morale, maybe you're always fighting and you can never agree and you can't run plays because people don't do what they're supposed to do and there's not good communication. Like, morale is kind of like the sum of the parts. How well does it work? So if you have good morale, people are happy, they're like doing their jobs well, they work together well. So he wants to boost morale. So he's going to provide the radio station with a free meal. So the manager and the owner both decide to collect data on what meal people would like to eat. The manager overwhelmingly gets results in favor of the salad bar. The owner, when he surveyed his people, overwhelmingly got responses that they wanted an omelet bar. Omelets. Omelets are awesome. So, what do you think could have caused this giant difference in the results that they got? What do you think could have caused this giant difference? Seth?
Maybe they advertised the omelet or said that the omelet tasted, it was like the world famous omelets or something like that.
So they had no advertising. All they did is they went and they asked them, what kind of like meal would you like to see? Like what kind of a food incentive or food prize? Olivia?
Well, that's probably what they wanted. So they went to people that they knew liked what they liked.
That is an option that I didn't think about. So how we could describe that by saying like they surveyed, because when you're asking a question, you are surveying. So they surveyed with bias. They asked people that they knew would answer what they wanted. That could be one reason. There's another big one that I'm trying to get us to. Pranav?
One may have used a systematic and one may, they both may have used a convenience sample.
They both systematically sampled every fifth.
Oh.
They both systematically sampled every fifth worker. James?
Because they asked different people.
Well, yeah, but how would these people be different? Zach?
It's like one of
Seth, don't be a jerk.
the person who got the salad bar results went and surveyed the people that worked the salad bar, and then
So we're talking about radio station workers and what kind of food they would want, right?
Could it be that one of them was in the morning and they wanted an omelet and then
Time of day that you ask people for information will bias their answers. So the omelet bar responses were probably morning workers. The salad bar responses probably came from daytime workers. That's why we're saying the manager and the owner separately, they could work at different times of day. And when they ask their people, the different time of day would affect the results that they get. So, the big thing here is place, like location, place, and time cause bias. Place and time cause bias. And to go back to what Olivia had said, surveying with bias, if I ask people in the morning versus asking people in the evening, that is surveying with bias. If the time of day, if I know that what I'm asking is affected by time of day, I know that when I'm collecting my data, it's biased. Right? A nice wedge salad, some blue cheese dressing.
Yes.
During the final episode, someday
I don't
you
want to
might
eat mold.
actually, every 6 years, all of your taste buds regenerate. So you just wait. You might come back and be like, hey, I really like blue cheese dressing. During the final, okay, so I have to let the video play for this one. Sorry, it won't make sense if we don't watch the video.
Every 6 years we gotta eat ranch to get used to it.
So every 6 years I'm gonna simultaneously throw up.
how'd you know?
Because I hate ranch. Ranch is horrible.
Especially salad.
And now, America, you have voted and voted as many times as you wanted. And as always, we have tallied the votes. And this week, just as we have every other week, the lowest scoring contestant will be eliminated. But America, tonight is different. Because tonight there will be only one contestant remaining, and that contestant will be the singer the country has declared is #1. Can you believe it? And we'll find out the results right after this commercial break.
Whoever watches American Idol or The Voice or any of those shows where voting matters, right? How do people vote for these shows?
They use Twitter.
They like text their answers.
You can text your answers, you can tweet your vote,
Instagram it.
you can Instagram, I don't know, maybe, probably. You can go online and fill out a survey. Does it limit you to how many times you can vote? Does it only let you vote once?
No. You can
No.
vote as many times as you want.
So sometimes it's as many times as you want. Other times it's limit 10 votes per method. So I could vote 10 times on Twitter. I could vote 10 times online. I could text my vote 10 times. I could call in my vote 10 times. So when they say America has spoken, this is the singer that America has chosen. Is that valid?
No, it's not yours.
No. Because why?
Alright, because it's kind of just like a small sample, I guess, sort of. Because there's the people that are watching the show.
Yeah. Do you think when I watch the show, I have a favorite? Like somebody that I think, oh, they were really good.
Yeah.
Do you think I vote?
No.
No, I don't care. I'm not going to cast a vote. So, the votes are biased.
Every time.
And they're biased because, hey, gentlemen, you should be writing. They're biased because they're not limited. He said you voted and voted as many times as you've wanted. So, they're biased because they're not limited. I think American Idol is 10 times per method. I think that's how they limit it. Pretty much, yeah.
You can.
If you want to waste your time doing it, like that. My sister and my mom, when they got really big into it, they used to vote. Like sometimes I was like, "You guys realize that your votes don't really matter?" And they're like, "Yes, they do." I said, "How many people do you think vote?" And I like ran through a math problem with them. Like, so you voted 4 times, right? Because you think that's gonna. So you put in 4 votes out of thousands and thousands of people that are voting. But then people are like, "Oh, well, why do you vote in the presidential election? Like your vote doesn't matter." So if you think mathematically, sure, it doesn't really make a difference, right? One number out of millions isn't going to really make a difference. But if every person or lots of people felt that way and said, my vote doesn't matter, I'm not going to vote, thousands, potentially millions of people would give up their votes. And for American Idol, who cares, right? Somebody's going to become famous. Most of them are going to stay famous anyways. But for the presidential election, even though I'm only a drop in the bucket, I'm 1 vote out of millions, it does matter to get out there and have your voice heard. So when I say 1 vote doesn't matter, do not take that and think that, like, really it doesn't matter. It's statistically, it's a very small change, but it does matter. That's where we'll stop for today. We will pick this up and finish tomorrow and probably start working on some probability. No. So you should be able to do your homework just fine. We'll finish the lesson tomorrow, but you should be able to do both homeworks. We'll finish the lesson tomorrow.